Okay guys, so now we got our graph made. So what do we do with this? What's cool about it though is that if you did a decent job at putting your pictures at the same height, we can see this ball. So every quarter second, so here's 0 seconds. My picture on my y-axis, I wanted to see my numbers, so I right-click this first picture, the time equals 0 picture, and go to object properties. And if you go to color, you can change the opacity of the picture. So I wanted to make it so that I can still see the picture, see where the ball is, but I can see the numbers too. So I changed my opacity to whatever this number is, 70. Okay, so anyways, what we're going to do is Geogebra doesn't know where this ball is in each picture. We can see it. That's the pattern that we're noticing. It's not a linear drop, which means every second it's falling the same distance. Like we said, it's speeding up. So as we go to the right here, time's going on and the ball is dropping every quarter second here, and we can see that it's creating bigger gaps, so it's definitely speeding up. Okay, so let's model this. Let's create an equation that it's going to explain this path. Okay, so what we need to do is put a point right on where the tennis ball is, or that big ball is, on every one of these pictures. Okay, so I'm going to make my point stand out though, so I'm going to change my color to maybe red, and then I'm going to make it a little bit bigger so I can see it. So now I'm going to just click where this tennis ball is, or this ball in our picture. So now we didn't have the camera completely still. This one's kind of hard to see. The ball's right on top of this white thing here, so right about there. So there's the ball. We can see points now. Now we have something that Geogebra can use. So we want to analyze the pattern in these points. Okay. So unless there's an easier way, this is the only way that I know how we can analyze. I want to take these points and put them in a spreadsheet so that we can analyze them, because a spreadsheet is just a computerized table. So I'm going to go to View, and I'm going to click Spreadsheet here. So what I want to do is I want to put these points in a column here. So what I've found is if you just type the name, so I'm going to type a capital O for this point here, the label of this first point, and when you hit enter it gives the coordinates of the point. So then I'm going to say P, and notice it's putting a point on top of that red point there as we make it in our spreadsheet, but that's okay. So now I'm just going to go, now notice the points that have a sub 1, how do we type that? We're going to type a capital M, because that's like the label of my next point here is capital M. And then I'm going to do the underscores. So you're going to hold shift down on your keyboard, and then you're going to hit the little minus button that's up by the 0 on the number line of your keyboard. So hold shift and hit that little dash button, which creates an underscore, and then we're going to type 1. So that's how we do subscript in Geogebra, is this little underscore. So when I hit enter, there's its point. So now I'm just going to go through and do this. Oops. So I'm going to pause my video, and I'm going to go ahead and just type all these points in, and then I'm going to restart it. So I recommend you do the same thing here. So I'm going to start talking when I have all my points done. Okay, so now I got all my points entered in Geogebra here. Okay, so now that they're in a spreadsheet, we can analyze it. So when I click on the A title of this column here, if you click on the actual A here, it'll highlight the whole column for us. And notice our options in Geogebra switch to spreadsheet options, so now we can analyze. I do want these points to stand out again, so I'm going to set their color to red again. So click on this, and there we go. We're going to make them red. Okay, so now we can still see those red points there. So make sure that your column's highlighted here. And we're now going to go to this one variable analysis, or the analysis toolbox here. And we're going to grab this 2 variable regression analysis tool. So our 2 variables again are speed, so time. Well, to find speed we need time and distance. So those are our two variables here, time and distance. So we're going to do the two variable regression analysis. We're going to take a look at our points here, and they're going to just be the XY coordinates like we have in the column. So we're going to click Analyze, and we can see now just the points themselves, the ball. So every picture here is a quarter second of time that's going on. So for every quarter second, the ball's dropping, and we can see where it's at due to time. Now our camera wasn't held very, we had someone holding it still, but yet it's moving a little bit. So we do have a little bit of variation in the points here, but this is a pretty good pattern. Notice it's not linear, and we can check that out real quick by doing a regression model. If you click the none here, just go to linear and click on linear. And we can see that this is the best fit line for that data, and it's not very good, right? You can see that the data itself is curved. A line is this nice straight line though, so a line isn't going to work. So what I want you to do is click on polynomial. So if you click on polynomial regression, 2 tells us the exponent. We want this to be a second degree. This is what we call our squaring pattern. Okay, so this is a quadratic pattern here. We're going to take a look at the parent function and build concepts to get up to this, but right now this is the pattern that's describing this here, and that actually fits the data really well. Okay, so I want to put this equation on my graph here, on my pictures here. So notice up here in the upper right of the screen we have this little kind of send to icon here. So when you click on that, we're going to copy to graphics view. So click copy to graphics view. Okay, and now we can get out of here. Here's our equation. So here's the pattern here. So now the data that we have collected every quarter second here are these points. Now we know exactly where the ball is at any time. So we could put in any interval, any time we want, and we could figure out its height based off of this equation here. Okay, so now save this Geogebra file with this picture here, because we'll be sending this into Edmodo tomorrow. Okay, and then we'll be talking about this when I return. But you should have your points here and your curve with your quadratic equation, which is just up here in our algebra window. Okay, so get that done for tomorrow. Thanks guys, enjoy.